Hi, Assalamualaikum warahmatullahi wabarakatuh. Welcome to Chapter 3, Differentiation. And here is the outline of Chapter 3. For your information, the main reference of this chapter comes from James Stewart. So should you be interested to get more information or more details on this topic, you can look up to this guy. And the title of his book is Calculus, 4th edition. Okay. Right, in this video, I'm just going to give a simple introduction to the idea of derivatives. Recall what you have seen in the last section of chapter 2, where the following equations are used in solving practical problems. So you can see that this expression here is similar to the expression used over here. And for the first one, this formula is used to find slope of a tangent line, and slope of a tangent line is denoted by symbol m. Whereas in this second problem given here, this expression is used to find the instantaneous velocity of an object at a specific time, and so for this purpose, this expression is labeled as VA, where V here stands for velocity. And you will see that these expressions given here, the two similar expressions given here, is also seen in this chapter, in this video, which is given by this one. And this is used to find the derivative of a function f at a number a, and that is represented by f prime a. So here I'm just going to give emphasis or give a definition to the idea of derivative. So before we move on to examples and so on, let's talk a little bit more about the idea of derivative. Okay, so when you talk about derivative, it is basically the measure of the rate. So you are measuring the rate at which the value of your function, the value of fx, changes with respect to the change in x. Okay, so basically there will be a change in x that will influence the changes in fx, the value of your function. And if you want to visualize what's going on with this statement here, you can imagine having a graph. So we have x and fx, and here we have some sort of a function, let's say represented by this curve. So this is function fx, and let's say you are interested on a specific point of x. So that point could be point A, maybe somewhere here. So x is equal to a, and if you obtain f prime a, basically you compute and you get a value of f prime a. So this is the value of f prime a, which represents the slope at point A. So f prime a here represents the slope at point A, and this is basically the same thing as the slope of a tangent line at point A. Okay, right. Let's look at the first example here. Find the derivative of this function at a number a, and we are going to use the definition given here. Okay. All right, so f prime a is equal to this is limit h approaches 0. Here we have fa plus h. This is just writing down the formula, and based on the above formula, I will substitute a plus h into the function given here, and so what you will get is you will get a plus h squared minus 8a plus h plus 9 minus, this is going to be another function where you substitute a into that function. So a will be substituted into fx. So you will get a squared minus 8a plus 9 over h. Next, let us try to simplify the numerator, and that will be a squared plus 2ah plus h squared for this one. And here it will be negative 8a negative 8h plus 9. And here if you take out the bracket, it will be negative a squared plus 8a minus 9 over h. Next, we can continue trying to simplify the expression here by cancelling the similar items, okay, with positive and negative sign. Yeah, so for example here, this is negative a squared, this is positive a squared, can be cancelled out, and this one negative 8a with positive 8a, positive 9 and negative 9. And so the expression here becomes limit h approaches 0, 2ah plus h squared minus 8h over h. And you can see that h appears in this expression here, therefore we can factor h out. So we have h is factored out, so we have 2a plus h plus minus 8 over h, and you can see that this can be cancelled out. So if you substitute 0 into h, the final answer that you get for this is going to be 2a minus 8. Okay, so that's the answer for the first question here, derivative at a number a. Next, we're going to use the answer to find equation of the tangent line to curve fx at point 3, negative 6. So this is point x and point y, and this point x also represents point A. So if you refer to the idea given here, basically this is at point A and you are asked to find the equation of the tangent line at this point. So this could be the tangent line, so you need to find the slope, and then you will need to come up with the equation, a straight line equation. Yeah, so right now we are going to find the slope. So m is the slope of the tangent line, and as I have said earlier, this is equal to finding f prime a, where a is equal to 3, and this is equal to 2 times 3 minus 8, and the answer is going to be negative 2. Okay, we are not done yet. We need to come up with the equation of the tangent line, and to do that we can use the formula y minus y1 is equal to mx minus x1. So y minus y1 is negative 6, so minus negative 6 is going to be positive 6. M is negative 2, x minus x1 is minus 3. Okay, and if you simplify this, you will get y is equal to negative 2x plus 6 minus 6, and this is equal to negative 2x. So here we go, that's the equation of the tangent line. So if you are interested to visualize this example here, we are going to start off with sketching the graph of the function. So this is basically the graph for function fx is equal to x squared minus 8x plus 9. So that's the representation of the function given here. And if you consider the specific point where x is equal to 3, so this is the specific point where x is equal to 3. This is the special point, and the point is called A. And at this particular point, the coordinate is at 3, negative 6. So this is the coordinate 3, negative 6. And at this particular point here, you will get the slope of the point, the slope at that point. So the slope is given by this purple line, and of course this is the same as the slope of the tangent line. Yeah, and based on your calculation just now, the slope is equal to negative 2. So you can see that it is going in this direction, so there is a negative sign, so m is equal to negative 2. And later on you have obtained the equation of the tangent line. So the equation of the tangent line is y is equal to negative 2x. So basically what it means is, if you visualize the graph, it's going to look like this. So this is the tangent line, and you can see that it touches point 0, so the intercept is at point 0, and that's why this is actually negative 2x plus 0, and we don't need to actually, you know, write down 0. It's just y is equal to negative 2x. So that's the idea, or that's the visualization of example 3.1. Okay, let's move on to example 3.2, where here is the derivative of some function f at a number a, and you are asked to find what is the function and what's the value of a. Right, so in order to answer this question, let us start off by writing down the definition or the formula which relates the idea of limit and derivative. Okay, so here is the definition for derivative. F prime a is equal to limit h approaches 0 fa plus h minus fa over h. So that's the definition which we have seen in the earlier part of the whole slides given here. And so what you have right now is this one. So you have this one, and I'm going to turn this expression into something that looks similar to this definition given here. So for example, x approaches 1 has to go. We are going to use the term h now. So you can see that at the bottom part, we need to have h instead of x minus 1. So what I can do is I can start off by considering, I'm going to consider letting h equals to x minus 1. Okay, so if I consider this representation, therefore I can see when x gets closer and closer to 1, x approaches 1, this one is going to be closer and closer to 0. So here I know that when x gets closer and closer to 1, h will get closer and closer to 0. So therefore, what I'm going to do next is I'm going to change the representation of this with something that has h in it. Okay, and again note that if you have h equals to x minus 1, therefore x must be equal to h plus 1. Okay, if h is equal to x minus 1, x must be equals to h plus 1. Okay, so I'm going to use this and substitute this information here accordingly into this expression here. So first I'm going to write down x approaches 1 with h approaches 0. At the bottom part, it will be replaced with h because h is equal to x minus 1. On the top part here, x will be replaced with h plus 1. So h plus 1 to the power of 9 minus 1. And interesting enough, you can see that now you have something that looks a bit similar, where you have h at the bottom part and you have something that looks like h plus 1. So here is a function that has a plus h. And what you can do next is you can try and visualize or write down that this is equal to something that looks 1 plus h, that looks like 1 plus h to the power of 9, and this minus 1 to the power of 9. So clearly 1 is the same thing as having 1 to the power of 9. I'm just trying to have the similar outlook for this one here over h. And based on this representation, we have something similar, and I guess you can see that the value of your function based on this comparing the definition with what you have over here, you can see that your function could be fx equals to x to the power of 9, and your a could be equal to 1. And if you're not sure what's going on, you can try to substitute a plus h into the function. So for example, if this is your function, fx is equal to x to the power of 9, so if you have f a plus h, that would be a plus h to the power of 9. If you have FA, that would be substitute A into this, you will get A to the power of 9. And if your A is equal to 1, therefore this one is equal to 1 plus H to the power of 9, and this one is equal to 1 to the power of 9. So this is clearly FA, and this is FA plus H. Okay, so we have the same outlook, which is FA plus H. This one is FA. Over here we have H, limit H approaches 0, and therefore this is the answers to this question. Your function is x to the power of 9, and the value of A is equal to 1. Alright, that's all for now. Thank you very much for watching.